What if I told you some of the smartest engineers on Earth still can't fully explain how a few ancient farm machines keep outperforming modern tech? No software updates, no AI, no touchscreens, just raw iron, gears, and genius from decades ago. These old combines don't just work. They survive abuse that would destroy today's million-dollar machines. They run after floods. They run after fires. Some haven't been shut off in years. And the scariest part, modern engineering can't recreate their durability. Today you'll see 10 old combines that refuse to die and leave engineers confused. Number 1. International Harvester 1460. When the International Harvester 1460 arrived in the late 1970s, it didn't just add another option to the market, it forced the entire industry to rethink what a combine could be. Up until that moment, most harvesters followed the same basic philosophy: thresh the crop aggressively, move it across straw walkers, shake the grain loose, and hope losses stay under control. It worked, but it was complex, space-hungry, and often harsh on grain. The 1460 challenged that tradition by introducing a single long rotor that handled threshing and separation in one smooth, continuous motion. On paper, it looked risky. Farmers wondered if a single rotor could really replace the proven Walker system. Engineers worried about clogging, uneven separation, and reliability. But once the machine hit real fields, those doubts faded. The 1460 proved that crop could flow through a combine in a calmer, more controlled way. Instead of beating grain loose in violent stages, it guided it through a steady spiral of threshing and separation. Grain quality improved, losses became easier to manage, and operators discovered something rare: a combine that felt predictable. What still confuses modern engineers isn't how the rotor works. They can model every airflow path and contact surface. What confuses them is how right the balance felt. The 1460 didn't rely on electronics to hide weaknesses. Its performance came from physical design, rotor length, cage geometry, and crop flow logic. Everything happened for a visible reason. If grain cracked, you knew why. If losses rose, you knew where to look. The machine taught you how it thought. Even today, many 1460s remain in active service. Not as novelty backups, but as serious harvest machines. They survive because they invite ownership. You don't need a laptop. You don't need permission. You listen, adjust, and keep moving. When something fails, it fails honestly. A belt snaps. A bearing growls. The machine tells you what it needs. Modern combines are more powerful and more precise, but many operators still describe them as black boxes. The 1460 is the opposite. It's transparent, it builds trust, and that is why, decades later, it still feels like a machine that arrived from the future and then quietly waited while the rest of the world caught up. Number 2. Case IH1480. The Case IH1480 took everything that made the 1460 revolutionary and pushed it into the realm of serious commercial harvesting. More power, more capacity, same rotor heart, same mechanical honesty. This was the machine for farmers who worked big acres but still wanted to feel in control of their harvest. The 1480 became legendary because it did something rare. It scaled up without becoming fragile. Many machines grow more complex as they grow larger. The 1480 grew stronger without losing its character. It still spoke the same language as the 1460, sound, vibration, crop flow. But it did it at a higher tempo. Operators didn't feel like they were managing a monster. They felt like they were commanding a powerful, obedient tool. What makes the 1480 so hard to explain in modern terms is its economic logic. It refuses to die. Farmers rebuild engines, replace wear parts, reinforce frames, and keep these machines earning. In a world where technology often becomes obsolete faster than it wears out, the 1480 flips the equation. It remains useful because it remains understandable. There is no digital barrier between you and the machine. It doesn't lock itself into reduced performance. It doesn't require a subscription to operate at full potential. If something goes wrong, you diagnose it the same way farmers have for generations. You listen, you look, you touch. The solution is mechanical, not administrative. Modern engineers can design incredible systems, but the 1480 exposes a weakness in modern thinking. Reliability is no longer just about parts lasting, it's about permission. Many new machines still work, but they stop working in ways the owner cannot resolve alone. The 1480 belongs to a different philosophy. It assumes the farmer is competent, it trusts the operator, and in return, it gives decades of service. That mutual trust is what refuses to become obsolete. Number 3. New Holland TR70. The New Holland TR70 was born in an era when straw walkers ruled. Most manufacturers were refining traditional designs, making them wider, faster, and more powerful. New Holland took a different path. Instead of improving the old system, it replaced it. The TR70 introduced twin rotors, splitting crop flow into 2 parallel paths that threshed and separated grain in a smoother, more controlled manner. At the time, it felt radical. 2 rotors meant new engineering challenges, new service routines, and a new way of thinking about harvest. Many farmers hesitated. They trusted walkers because they understood them. The TR70 asked them to trust a future that hadn't proven itself yet. But in the field, the TR70 told a compelling story. Crop moved with rhythm instead of violence. Grain damage dropped. Performance became consistent across changing conditions. Instead of relying on shaking and bouncing, the machine relied on controlled motion. It treated harvest as a flow problem, not a beating contest. What confuses modern engineers is why a design from the mid-1970s still feels contemporary. The reason is uncomfortable, because it solved core problems physically. It didn't wait for computing power to mask inefficiencies. The crop path itself was the intelligence. The TR70 didn't feel like a prototype. It felt like a finished idea that arrived before the world was ready. And instead of fading away, that idea grew. Twin rotor technology became a long-running philosophy, not a dead-end experiment. In a time when machines are constantly updated, the TR70 stands as proof that some answers don't need revision. They need patience. Number 4. Gleaner N6. While most of the industry argued about walkers versus axial rotors, Gleaner asked a different question. Why must a rotor run front to back at all? The N6 answered by turning the entire concept sideways. Its transverse rotor sat across the width of the machine, using a 360-degree cage to separate grain around nearly the entire circumference. This wasn't a cosmetic difference, it changed the rhythm of the machine. Crop didn't rush forward in a straight line, it wrapped, rolled, and released. Separation happened evenly. The machine felt balanced. Operators often described the N6 as calm under load, even when capacity was high. What modern engineers struggle to explain is the emotional bond operators form with this machine. The N6 communicates. Adjust a setting, and the result is immediate. There is no delay, no algorithm deciding whether your input matters. You and the machine exist in a direct loop. That loop creates confidence. You don't feel like you're supervising a system. You feel like you're driving a tool. The N6 also proves something uncomfortable. Innovation doesn't always mean more layers. Sometimes it means changing direction entirely. Gleaner didn't add intelligence, they reshaped physics. In today's world, complexity is often the default. The N6 shows that elegance can come from less, not more. And that is why, decades later, it still feels like a machine that thinks with you, not for you. Number 5. Gleaner N7. The Gleaner N7 arrived like a statement of intent. It wasn't subtle, it wasn't modest, it was huge for its time, capable of running massive headers and swallowing acres at a pace that made other machines look cautious. Yet what truly made the N7 legendary was not its size, it was the fact that it didn't become complicated because it was big. Most large machines suffer from the same fate. As capacity grows, fragility grows with it. More belts, more shafts, more stress points, more systems that must coordinate perfectly. Many high-capacity combines feel like they're constantly balancing on the edge of their own limits. The N7 refused that pattern. It was designed as a brute, but a disciplined brute. Its transverse rotor system scaled up without losing its clarity. The crop path remained logical. The adjustments remained understandable. Operators who ran N7s often speak about them with a strange mix of respect and affection. They weren't smart machines. They didn't think for you. They responded to you. When the crop changed, you changed the settings. When losses rose, you knew where to look. The machine didn't hide behind automation. It trusted the human behind the wheel. What modern engineers struggle to recreate is this exact combination: extreme capacity with emotional simplicity. Today, when a combine grows larger, it usually grows more abstract. The operator becomes a manager of systems rather than a driver of mechanisms. The N7 belongs to a time when even the biggest machine in the field still felt like a tool, not a platform. Its performance came from physical truths: rotor diameter, cage area, airflow, and structural strength. There was no digital safety net. The steel had to be right. And because it was right, the machine aged well. Even decades later, N7s are remembered not as old tech, but as bold engineering. The N7 proves something uncomfortable for modern design philosophy. Power doesn't have to mean opacity. You can build something massive without making it mysterious. And once farmers experience that balance, they never forget it. Number 6. John Deere 6600. The John Deere 6600 didn't become legendary because it shocked the industry. It became legendary because it earned trust. This machine defined what a good combine felt like for an entire generation of farmers. It wasn't radical. It wasn't experimental. It was solid, predictable, and endlessly practical. The 6600 taught farmers how combines behave. It responded clearly to adjustments. It showed its problems openly. It rewarded attention. Operators learned to read it the way a mechanic reads an engine: by sound, by vibration, by grain quality in the tank. It didn't filter reality, it presented it. That honesty is what modern engineers struggle to replicate. Today's machines often protect the operator from discomfort. They smooth out feedback. They decide what matters. In doing so, they also remove a layer of understanding. The 6600 never made decisions for you. It demanded that you be the intelligence. This created a powerful sense of ownership. You didn't use a 6600. You knew it. You remembered its moods. You recognized its noises. You anticipated its needs. The machine became part of your rhythm. That relationship is why so many 6600s are still alive. They were not abandoned because they never betrayed their owners. They may be slower than modern combines. They may lack comfort, but they remain emotionally reliable. Modern engineering can recreate the parts. What it cannot recreate easily is that bond. The 6600 represents a time when machines were designed with the assumption that the operator was competent, curious, and responsible. It trusted the farmer, and in return, farmers trusted it for decades. If you want, I can now continue with points 7 to 10 in the same long, detailed style. Number 7. John Deere 8820 Titan II. The John Deere 8820 Titan II came from an era when engineers designed machines for reality, not theory. Harvest is not clean, it is not gentle, it is not predictable. Crops vary, weather turns, dust fills the air, and time becomes the enemy. The Titan II was built with that chaos in mind. It wasn't designed to impress in a showroom. It was designed to survive in the field. Everything about the 8820 feels deliberate. Shafts are thick. Frames are heavy. Drive lines are overbuilt. It doesn't rely on fragile precision. It relies on physical strength. This combine expects abuse. Long days, heavy loads, hot afternoons, uneven ground. It doesn't complain. It absorbs. Modern combines are incredibly smart. They adjust themselves. They monitor everything. But that intelligence comes with sensitivity. Sensors fail. Software glitches. Systems argue with each other. The Titan II has none of that. It does not negotiate. It does not think. It simply works until something physically stops it. That's what modern engineers struggle to justify. A machine that solves stress with steel instead of software. The Titan II does not protect itself by limiting performance. It protects itself by being strong enough to endure. When it breaks honestly. A belt snaps, a bearing fails. You fix it and move on. There is no lockout, no reduced mode, no dependency on external authorization. This machine reflects a philosophy that is becoming rare. Build it strong enough that it doesn't need babysitting. Build it so the owner can keep it alive. Farmers still respect the Titan II because it never pretended to be anything other than what it was, a brutal, dependable workhorse. It doesn't impress with elegance, it earns loyalty with endurance. Number 8. Claas Dominator 108. The Claas Dominator 108 feels like a machine designed by someone who understood harmony. Every system flows into the next. Air, crop, motion, and timing feel coordinated, not stacked. It doesn't feel like a platform with features, it feels like a single idea expressed in steel. Where many machines evolve by addition, the Dominator feels intentional from the ground up. Its threshing, separation, and cleaning systems behave like parts of one organism. Nothing fights, nothing feels forced. You can sense that the engineers were solving flow, not just function. Modern engineering often layers solutions. When something becomes inefficient, software compensates. When systems conflict, automation intervenes. The Dominator doesn't compensate, it aligns. Problems are prevented by geometry, not hidden by algorithms. Operators often describe these machines as smooth, not in speed, but in behavior. They don't surge, they don't panic, they don't become unpredictable when conditions change. They remain readable. That readability is what makes the Dominator so enduring. You are never guessing what it's doing. You are never separated from its logic. You remain in control. Modern engineers can design machines with greater precision, but coherence is harder than accuracy. The Dominator reminds us that a machine can be powerful without being complex, advanced without being abstract. It doesn't feel like an old combine. It feels like a complete idea that simply refuses to age. Number 9. Massey Ferguson 760. The Massey Ferguson 760 proves that traditional doesn't mean inferior. In a world racing toward rotors and automation, the 760 remained grounded in a design philosophy that valued gentleness, predictability, and mechanical clarity. Walker machines separate grain differently. They shake, they breathe, they rely on rhythm rather than force. When tuned correctly, they treat crop with respect. Grain comes out clean, straw remains usable, the machine stays calm. The MF760 excelled because it respected this rhythm. It did not chase extreme throughput at the cost of stability. It aimed for consistency. In mixed conditions, green patches, damp straw, uneven stands, the 760 did not fall apart. It adjusted gracefully. Modern machines aim for perfection. The 760 aimed for reliability. That difference matters when clouds gather and rain threatens. You don't need the perfect harvest. You need a harvest that finishes. The 760 forgives mistakes. It tolerates wear. It doesn't punish slight misadjustments. It continues working even when conditions are less than ideal. That forgiveness is rare in modern machines, which often require precision to remain efficient. Engineers understand Walker physics. What they struggle to explain is why farmers still trust them. The answer is simple. Walkers behave predictably. You can feel them working. You can sense when they're overwhelmed. You can adapt. The MF760 remains respected because it never surprises its owner. And in agriculture, surprise is the enemy. Number 10. New Holland TR85. The New Holland TR85 represents the maturity of the twin-rotor philosophy. It doesn't feel experimental, it feels complete. Everything the earlier TR machines promised, the TR85 delivers with confidence. Two rotors work in harmony, guiding crop rather than punishing it. Threshing is smooth, separation is consistent. Grain quality remains high even under stress. The machine doesn't demand perfection, it absorbs imperfection. That is what modern engineers struggle to replicate: forgiveness. The TR85 tolerates wear. It tolerates operator error. It tolerates variation. You can be slightly off on rotor speed, slightly wrong on concave clearance. The machine still performs acceptably. It doesn't collapse into inefficiency. Modern systems are precise but fragile. They require correct conditions to function optimally. The TR85 functions because it is generous. It doesn't argue. It doesn't lock itself. It doesn't wait for updates. It waits for you. You are not a supervisor. You are the intelligence. Even today, many TR85s remain in service. Not because owners can't afford new machines, but because this one still works. It still makes sense. It still belongs to its operator. Modern engineering can explain how the TR85 works. What it cannot explain is why a 40-year-old machine still feels finished. And that is the mystery these old combines carry into every harvest. After seeing these machines, one thing becomes clear. Progress doesn't always mean improvement. Somewhere along the way, we traded eternal strength for temporary convenience. These old combines aren't just metal and gears. They're proof that humans once built things meant to outlive themselves. If a machine from 50 years ago can still harvest fields today, what does that say about the ones we build now? Drop a comment. Which combine shocked you the most? And if you respect unstoppable machines, hit subscribe, because legends like these deserve to be remembered.